All right, well, let's go ahead and get started. It's 11. So welcome again. Hi, my name is Lisa Edens, and I'm the program coordinator with the Colorado Alliance for Environmental Education. I just want to welcome you to our monthly webinar series here today. We are lucky enough to have Joseph Kursky here today to talk to us about teaching environmental issues and phenomena with the Living Atlas of the World. And just before I introduce Joseph, if you're not familiar with the Colorado Alliance for Environmental Education, we're a network, a professional association of environmental educators across the state who together reach about 800,000 learners here in Colorado. And our mission is to advance environmental education by fostering collaboration, mobilizing support, and driving excellence in the field. And so one way that we hope to drive excellence in the field is through our monthly webinar series. We try to choose topics of interest to the EE community, and we have a lot of upcoming events I just want to share briefly with you. Next Tuesday is our second of 3 webinars to learn about Colorado's environmental education plan and to provide your feedback on that. The following week, we are really excited that the Center for Diversity and the Environment is hosting a full-day workshop on March 10th, all around rooting in equity, diversity, and inclusion and justice. And this is a $10 workshop with a $95 scholarship. So they're offering it for a really reduced fee. So that would be a great one to check out. And then 2 weeks after that is our March webinar, which is how to tell a more effective story about environmental education. And so we have been working with the Frameworks Institute for about a year now on just, the language that we use and how we can better communicate the impacts and importance of environmental education with our communities. So that'll be a great one to check out. And those are all already, registration is up on our website. And then on April 9th, we're going to be hosting a spring EE Unconference, which is traditionally kind of our event hosted by the West Slope. But this is open to all environmental educators across the state. It's kind of like an open space event where participants will be just sharing information with one another around topics of interest. So definitely a lot going on, and all of that information is up on our website to check out. I know everyone's an expert in Zoom, but just a couple things to be mindful of. It's always great to keep your line muted while others are speaking to reduce that background noise. You guys are doing a great job so far. Please use the chat function. I hope that this can be as interactive as possible through a virtual platform. So please share your thoughts and ideas, your questions, your resources, anything. Use those emojis in the chat. That's always great to see. If you haven't already, it'd be great if you could introduce yourself in the chat, your organization or your location where you're joining us from today. And I was saying earlier, if you're in Colorado here, feel free to share how much snow you got last night. I said I was out in Golden and we've got about 7 or 8 inches here. You will receive the recording from today, so don't worry if you miss something, or don't worry about taking copious notes there. And then before we get started, one way that we can support equity is by beginning our day by acknowledging our history of colonization and oppression, and that it is still continuing today. It's important to remember that what we know as Colorado today was the traditional home of the Apache, Arapaho, Cheyenne, and Pueblo tribes, the Shoshone tribe, and the Ute Nation. And historically, environmental education has been tailored to white communities, and the contributions of Black, Indigenous, and people of color have been excluded from our narrative. Black, Indigenous, and people of color have vibrant, rich histories and cultures that contribute to our field, and we all have the responsibility to continue working to change and challenge the systems that continue to allow inequity and injustices to exist. All right, well, let's get to our awesome presenter here, Joseph Kursky. And this is, I think, the 3rd webinar that he's done for us in the last several years. So I'm so excited to have him here today. And let me just briefly tell you a few things about Joseph. He is a geographer with a focus on the use of geographic information systems, or GIS, in education. He has served as a geographer in the 4 major sectors of society, including government, academia, private industry, and nonprofit organizations. He has authored 75 chapters and articles on GIS, education, physical and cultural geography, math, fieldwork, teaching and learning, and related topics. He is active in conducting professional development training for primary and secondary educators, and he's authored or co-authored 7 books, including his most recent, Interpreting Our World, 100 Discoveries That Revolutionized Geography. So welcome to Joseph. I'll pass it on to you.
Wonderful. Well, thanks, Lisa, for the very kind words, and welcome, everyone. We are going to have a fantastically geospatial time today, exploring the living atlas of the world. There's a couple reasons why we call it the living atlas, but one of those is that it's dynamic, just like our Earth. So I think you'll find a lot of nuggets in here useful for your work in environmental ed, no matter if you're at a university or a community, technical or tribal college, primary, secondary school, informal education, environmental ed center, etc. So as Lisa said, and I love the CAEE, so thanks, Lisa, for all your support over the years. I don't intend for this to be the end all be all, okay, now go forth and do some of this mapping and spatial analysis with the Living Atlas, and we will never connect again. Feel free to connect with me on any of these methods. I'm very active on various platforms like LinkedIn and social media of various kinds. So I'd love to keep in touch with you. And I'm very passionate, like you all are, about exploring and understanding and making wise decisions about our Earth. In fact, I've got 5,000 videos on that Our Earth channel, 5,000. So I'm very passionate about all of this. Much appreciated. So again, that's my contact information, but we'll chat more going forward. Okay, one of the things that I just wanted to lay out here at the beginning is that, Joseph, why are you so passionate about the Living Atlas and of these other tools that we're going to dig into today? Well, it comes down to this. When you think about issues on our planet, biodiversity loss, racial and social inequities, climate, ocean acidification, land cover, land use, urban sprawl, energy, water, you name it, they're all spatial. They all have a geographic component to them. And in understanding and then solving those requires spatial thinking. So this tool right here and geotechnologies, which we're going to get into here in a bit, geographic information systems, remote sensing, etc. But I believe very firmly, with all my heart, actually, that it has to begin in the education system. We can't wait for students to get these skills and these tools and these perspectives just with on-the-job training. It really has to begin with all of us in the education sector. So that's why I am very passionate about all of this and why I believe it actually matters. I'm not going to bore you with all of my pathway and background, but again, why should he listen to Joseph? Well, I'm not the end-all be-all person on environmental ed or geospatial technologies in education, but for many years, I actually worked in the federal sector, U.S. Geological Survey as a geographer and cartographer, NOAA, Census Bureau, and now at ESRI, Environmental Systems Research Institute. So that's why Lisa and I get along so well, environmental ed, environmental systems. And I also, like many of you, love teaching, love interacting with students and faculty, deans, etc., in multiple levels of education. And that's what's nice about these geotechnologies. They span STEM and social studies, history, mathematics, so many disciplines that we all are teaching. So I teach at several different universities, and as Lisa said, I love working with K-12 educators and do a lot of PD online and face-to-face. So that's my pathway. Where does ESRI fit in? Environmental Systems Research Institute. Well, think of us as your industry partner in education. We all have the same goals here, and so I think it's important as we go forward in this decade to have partners in nonprofits, in industry, in government agencies, again, to nudge the spatial awareness and the environmental awareness and the environmental thinking and the use of tools like geographic information systems forward. We're all in this together, so we need each other. And so please consider us as your industry partner in all this. We've been at this since 1992, so it's not like yesterday we had an edict from our CEO saying, hey, we need to be involved with education. That's not the case. It's been happening since, again, for about 30 years now. And the primary tool that we're actually going to use is something called ArcGIS Online, which is the ESRI branded geographic information systems set of technologies. And it's cloud-based, just like you have your music online. Yeah, you might have some things on your local device, but it's great to access ABBA's greatest hits wherever you are at any time. That was a band, by the way. And it's great that you've got ways of collaborating on a paper with colleagues, or students can collaborate. You've got Google Drive, you've got OneDrive and Dropbox, etc. Those are cloud-based tools, right? Nothing to install. It just, as long as it works, you're happy. Same thing with geographic information systems. It's evolved into this cloud-based platform. Now, why does that matter? It matters for several reasons. First of all, these environmental issues that we talked about, they don't stop at disciplinary boundaries, right? They're not just for the economists and not just for the city planners and not just for the wildlife biologists. We need a diversity of people weighing in on these problems. So they span disciplinary boundaries. They also don't stop, of course, at political boundaries, right? Cities, counties, states, countries, they span all of those things. And they also, third and last, don't stop at physical boundaries. They're not one watershed or one ecoregion, right? They span all of those things. And so it's great to have this cloud-based environment where we can communicate and collaborate and share methods, data, curriculum, etc. And for you as an educator, hey, nothing to install. All you need is a web browser and a halfway decent connection, and you're good to go. Okay. Now, the education page that I'm screenshotted here is our ESRI page. And if you look at the about, we've got 3 goals: education, sustainability, and science. That is our 3 goals, and we're sticking to them. And that's been our 3 goals since 1969 when we started. Now, a little bit of geo geekiness, not too much though, but what platform are you using here today? You're going to be using pieces of this cloud-based ArcGIS ecosystem. It contains maps. It's got satellite images of various kinds and various dates. It's got map layers, sort of the Lego bricks that go into making maps and looking at things spatially. Web mapping applications. Lisa was mentioning past workshops. I conducted one on story maps, for example. We could do another refresher because the platform has evolved and it's more powerful and easier to use than it was in the past. So story maps, some of you have maybe heard about those or used those or seen those or created those with your students. So that's a web mapping application. That's part of this platform too. We also, Lisa and I were just talking before the session when all y'all came on, ustedes, vous, y'all, all y'all, but about Survey 123, tools that you can go out in the field and collect data and then map it and analyze tree species, water quality, litter, whatever it is that you are interested in. And then finally, these spatial analytical tools, like how much of this certain region has a double hazard, has a hazard of a flood and a landslide. What regions in my county or in my city or in my state or my ecoregion have double hazards? Not just looking at that on a map and kind of eyeballing it, but you can actually run spatial analysis tools to determine exactly which polygons, which areas in that area would be a double hazard, just as an example. Now, my colleagues and I on this education team here at ESRI, we're all about, hey, here's some data and here's some tools, and now, go forth, live long and prosper and use these. We're all about, we understand, we're educators too, just like most of you on the webinar today. We understand that it takes several components to make anything successful, especially technology-wise, right? Especially when it's rapidly evolving, and also many of you are probably all of you are teaching online right now. It's like, how do I use this online? So there's all kinds of things happening. And I salute you for wanting to be innovative educators, that I know you are, especially at these, disruptive times, because you've got a lot going on in your world, I realize. So it is, okay, what software are we going to use? How do we make it available? What curricular pieces can I sort of latch onto to start in this journey? Professional development, like we talked about, including today's webinar. How do I network with other educators that are interested in some of these kinds of things? So it's all those components to make it successful. And okay, let's step back a moment and talk about, okay, the US Department of Labor way back in 2004 said there are 3 hot fields for the 21st century: nanotechnologies, biotechnologies, and geotechnologies. And today we're going to be firmly anchored in the next 3 hours with geotechnologies. Just kidding, we don't have 3 hours. I just want to make sure you were on your toes there. But geotechnologies, what are the geotechnologies? Okay, geographic information systems. In the past, when I would conduct PD for educators, it was, oh, Joseph, now I've got to install software and I have to have a decent lab and all those other tech barriers. That meant that, thinking of the Rogers diffusion of innovations curve, only the innovators and early adopters actually did it because there were some tech barriers involved. Now with the cloud-based environment that I talked about earlier, a lot more educators are able to use these tools. Remote sensing, looking at the world from space. It could be, or an aircraft, or a UAV, or a drone. That's part of the geotechnologies and global positioning systems, or more broadly, global navigation satellite systems. Now, why use geotechnology in society? Why is this actually being used? Well, it is being used outside of education by your city and county government, by nonprofits, by private companies, by academia, et cetera. It's to solve problems. That's why geotechnologies were invented, to solve problems about land use, energy, water, et cetera. Health. Speaking of which, you've all seen the JHU coronavirus dashboard. That's built on, it's built on the same technology. This is all ArcGIS Online. So you've all seen this. Anybody with a phone or a tablet or a laptop in the last year, sadly, has seen this dashboard. We could have a webinar on how to build a dashboard, because this is all part of these tools that you've got at your fingertips. Wish I could get excited about this. Anyway, but secondly, though, it's all about building a more sustainable, healthier, happier world. That's really why geotechnologies are being used in society. And then you might say, well, Joseph, why do we use it in education? Not just because it exists, right? You as educators have to think about, what is the most appropriate tool to accomplish your educational goals and to meet those standards, those content standards? Okay, so you can't use every single tool that's out there. I can't either. So what tools do you think would be the most beneficial to teach X topic? And I just submit to you all today that geotechnologies is oftentimes the tool of choice, because it's not about the tools. It's about this tool. It's developing spatial literacy and looking at patterns and relationships and trends and connecting students with their community issues and solving problems interdisciplinarily and so on. It's all about the whys of where. I like to think of it as what's where, why is it there, and why should we care? What's where, why is it there, and why should we care? So that's really why geotechnologies is used in education. And we're all about this inquiry cycle of asking a good question, acquiring some data. We're going to use that today. We're going to explore some of it. We're going to analyze it. We're going to act on it. Hopefully, like if I collect data on water quality or tree species or litter or something like that, hopefully there's a little bit of an action item there. Okay, you've gained some knowledge and you've gained some skills. What are you going to do about it? Can you do anything about it? And then that leads to additional questions and the cycle continues. So that's really where we're anchored. Now, again, thinking about, okay, Joseph, how is this used in education? There's these four main categories. So teaching GIS. There's actually some high schools, East program in Arkansas, the Virginia Geospatial Semester, and a couple here in Colorado as well, that actually are teaching geotechnologies in a secondary school, usually in a high school, occasionally in a middle school. There's also, though, more commonly at the K-12 level, and as you might expect, teaching GIS is actually a lot more common in community technical colleges. Yeah, I know many of you are in Colorado. Every single college and university in Colorado has a GIS program because it's in such high demand. And I know there's some people from other states, Idaho State, University of Idaho, they all have GIS programs. So teaching GIS. Then teaching with GIS, using it as a tool, is more common in primary and secondary. So I'm teaching environmental science, I'm teaching math, I'm teaching history. I'm going to use these dynamic maps and these tools at my fingertips. And then there's research being done using geotechnologies. Again, usually at the university level, where faculty, students are using GIS as a research tool to look at biodiversity loss in a certain region, et cetera. Now, I used to work at USGS, as you know, and I love paper maps, okay? I've got a whole house full, a whole office full, maybe you do too, of paper maps. They're useful. They're limited, though. They're limited on scale, date, themes, or content. You can't add data to them. You can't change the date. For example, I used to show this dynamic planet. That was one of my favorite USGS maps of all time. I still have it's a big wall map. And that is great. It's got plate boundaries, earthquakes, volcanoes, and major tsunamis. Okay, but it was printed in 1985-ish. And you can't zoom in on Japan 2011. You can't zoom in on Indonesia 2004, et cetera. So it's got limited capabilities, still useful. And for certain lessons, that might be the thing. But as I'll show in a moment, geotechnologies with the Living Atlas of the World lends that to be a little bit more dynamic. And then finally, in administration, school districts use GIS or geotechnologies to route their buses. University and college campuses, they use GIS for campus safety and mapping all of their electric and gas and water lines on campus, et cetera. Now, I touched on this a bit ago, and I'm not going to read all this to you, but again, teaching with geotechnology is becoming easier to use and more powerful every time the platform updates. And the Living Atlas is a dynamic library of rich and deep content. So I highly encourage you to take a look at what we're going to do today. Now, what is in the Living Atlas, Joseph? Well, okay, here are some content categories. So you've got maps, as you would expect. You've got things that are trending. For example, we've got a new, if we have time, I'll show you the new Mars rover 3D tool. I mean, it's fascinating, and you can compare, for example, sizes. You can teach about angles. You can teach about distances and measure distances across craters and across Olympus Mons and across the Valles Marineris, and put California or Colorado on top of Mars and look at scale. And it's just fascinating, but it's all built on the same technology and a lot of other things that you see here. And getting into it a little bit more deeply, here you can see the layers on the left side, but the main thing is on the right side is that they're actually ready to use right now. And they're from authoritative sources. What do I mean by that? I mean NOAA, NASA, State of Colorado DNR, the EPA. It doesn't mean they're perfect, right? The layers are not perfect. Maps are representations of reality, for one thing, and they're imperfect. We've got to cast maps on a oblate spheroid. It's not a perfect sphere, for one thing. And then we've got to symbolize it. We've got to classify it. We've got to figure out what's the boundary between this ecoregion and that ecoregion. Is it really a boundary? It's probably a zone. So maps are imperfect by their very nature, very useful, but recognizing that, I think, is an important part of teaching with geotechnologies. And I have, if you want to go there at some point, I have a blog that's updated every week about that very issue, being critical of data, including, and maybe especially, map data. Maps have this sort of air of authenticity, and I don't want students to just say, hey, that map is online and it's digital and it's on the web, so therefore I can trust it. That is the purpose of this spatial reserves data blog, spatial reserves. And there's some short essays in here of exactly what I'm talking about. So if I go to everyday examples of being critical of data, I've got some fun, but hopefully instructive examples of that exact thing. George Mason University, do a search on that on Google Maps. Underneath it, it says simple Chinese fast food chain. Oh, really? I thought it was a major research institution. Interesting. What about this one? Oops. Orientation matters. Okay. What about this one? Internet of Things. We get feeds that we'll talk about in a moment coming into the Living Atlas of the world. I know it gets hot in Texas, but this was online actually for a whole year before it was corrected. And so it's really hot, it's really windy, it's really, it's like Noah's flood coming down. And the only thing that's normal is the pressure. So even Internet of Things feeds coming into maps have errors. And lastly, I thought I was a pretty big Fab4 fan. This is obviously not a map related, but still be critical of the data. I've never heard of A Day in the Sky before. How about Penny Lance? Penny Lance is in my, never heard of that song before. It's not really an album at all. It's someone's playlist and they misspelled half the songs. So be critical of the data. I just can't emphasize that enough. If we can get that across to our students, that will be a good skill for their whole life long. So here are some additional things that come into the Living Atlas. I mentioned Internet of Things. So you've got things like stream gauging stations. You've got weather feeds. We'll explore those in a minute. You've got wildfire perimeters, etc. So you've got this dynamic content coming in to the Living Atlas. Couple more examples here. Air quality, protected areas, and so on. Okay. All right. Couple of categories to kind of get you excited about this. There's something for everyone, really. The Hurricane Aware app. This always becomes really important, right, in late summer and fall. So it's something I usually teach with, especially if I'm doing a professional development for educators right around that time of year. Climate trends. We just put some new agricultural census data in there. And if we have time, we'll look at that. You know, where's the wheat versus the corn versus the cotton? And then why are those crops grown where they are? So some of it is, you know, you can talk about land use and irrigation. You can talk about climatic influences. You can talk about land use, landforms, so much there. And it's not just on land. There's a lot of good ocean data in there that we'll definitely explore today. Okay. All right. ecological marine units, is that we'll definitely do that. And also this living atlas is not just something that someone created in his or her garage, okay? It's not just some little thing this is a major effort. There's something like $60 million a year poured into the living atlas to develop all those content layers and to work with data providers and so on. And it's tied to major initiatives like E.O. Wilson's Half Earth Foundation and initiative, the mapping biodiversity information, and other things that are, again, major initiatives. They need the data. And so this isn't just for education. They actually are used in major research initiatives. Now, one note about content types. There's different items in the Living Atlas. And there is a lot most of it is actually open just in a web browser without signing into anything. And this is an important note for you educators. When you get, and I have an example where we're going to get to a premium content type or even a subscriber content type where, remember, this is all part of ArcGIS Online. And there's a lot you can do in ArcGIS Online without signing in. So the bell's going to ring in 5 minutes. You need to pull up ecoregions of the USA along with maybe watersheds. Okay, done. Don't need to sign in to do that. But if you want to dig deeper in several ways, you want to access some of the premium content type, and you want to maybe have the students save their own maps and data layers, maybe, and create a story map or use the Survey 123 tool I was talking about, they're going to need to park some content in that platform. And in order to do that, just like when you put things in Google Drive or OneDrive or Dropbox or something like that, you have to have an account, okay? But the good thing for you educators out there is that primary and secondary school, homeschool, private school, free. It's all free. For you folks at the community college and university, you probably already have an access to the ESRI GIS technology. And we can talk more about that later. But the point is, you don't have to worry about it either way. But for some of those layers, you're actually going to need, and I'm going to direct you to where can you get a actual ArcGIS Online account. But we're going to first start with things that you don't even need an account for. So this is what we're going to do here in the next, short bit together. We're going to explore the Living Atlas via the website. We're going to actually use some of the apps that are there, which are really compelling. And we're only going to have about a minute with each one of these things. We're going to use the Living Atlas content inside this ArcGIS Online mapping and spatial analysis platform. And then maybe what we can think about for workshop number 2 is linking your content, your own data that you collected with students to the Living Atlas. So it's in other words, it's your data. How do you work with your own data? Ooh, fascinating. So these are a couple of things that we're actually going to do here in the next short while together. Okay, the first thing I'd like to do is I'm going to go to a couple of the apps, okay? And one of them is this Wayback Imagery. And I told myself I wouldn't do this, and I've just overwritten my, this probably happened to you as well. And then we're going to skip down to the slide. Okay, I should have opened that in a new tab. That's all I was getting at. The Wayback Imagery. Now, you've got the capability here to look at a lot of different phenomena around the Earth. And again, this could be the whole workshop right here. This Wayback Imagery goes back to 2014-ish, but you've got high resolution imagery. In the upper left, you've got a swipe tool. Now, you've probably seen these in various maps over the years. Now, you can look at here, we're talking about southwest side of Las Vegas. Well, gosh, in 2014, as you can see on the right, I've got a field of probably rattlesnakes and sagebrush, and now there's a big IKEA there. So this is a tool where you can look at your neighborhood. How has the school campus changed over the last 7-8 years? How has Las Vegas changed? Let's scroll out with the same tool. And now let's go ahead and scroll over here and talk about another environmental issue. And that is, kind of looks like the water level in Lake Mead, which, as you know, is a reservoir, is declining from 2014 to 2020. I can change the dates over here as I wish. But the point is, you can teach about, hey, what's where, why is it there, why should we care? Who cares if the lake level declines? Okay, let's talk about sustainable cities in semi-arid and arid environments. Let's use the same tool to look at glacial retreat. Let's use this same tool. This is global, to look at coastal erosion, expansion of agriculture in Saudi Arabia, the Three Gorges Dam, volcanic eruptions, landslides. I mean, you've got this, again, this fascinating, if we want to look at coastal erosion, right, we could look at the chalk cliffs. And if we had more time, we'd actually zoom in a little bit more detail and spend a little bit more time on this. But even taking this, I mean, look at the retreat is of the cliffs in this south part of England, just in the last 7 years. I mean, it's almost going to take out this building shortly. So the point is, you've got this amazing tool right at your fingertips, just with this one Living Atlas app called the Wayback Imagery. Let's look at another one that I use often in instruction, and that is it's an illustration of the Living Atlas, but also of these Internet of Things feeds. So now you've got not real-time data now, you've got a variety of water-related variables on the left side. Let's take a look at precipitation. So again, only a minute on this, and I wish we had more time, but you click in the Amazon. Okay, it's not a winter and summer phenomenon, right? It's the wet season and the dry season. So if this is part of your curriculum, this could be a nice supplement to, okay, students, when is the wet season? Well, gosh, it looks like, October, November. The dry season every year looks like December, January, February, right around this time of year. And notice the trends over time. And you can export this, as you can see here in the lower left, you can export it as a comma separated value file, so you can bring it into Excel and do some further analysis. Well, gosh, let's say this was part of your lesson on, or your lessons on climate. Southern Libya, there are whole months of the year with zero precipitation. Okay, well now what about the population density in that area? What is this? Well, okay, part of the Sahara, etc. Depending on the age level of your students, right, you can go into this in a small way or in a larger, deeper way. So again, just with one tool, and this one's called the Water Balance app. It's all part of the Living Atlas, and thinking of the dynamic nature, the living part of the Atlas phrase, that next month we'll have the November 2020. So it's not real time. There's usually a lag of 3 or 4 months, but it won't look the same, right? Next month, we'll have additional information in there. Hey, let's look at, Southeast Texas. Well, gosh, what was happening in August 2017? It was a major hurricane, right? No wonder we've got this huge amount of precipitation. And notice over time that it's actually gotten a little bit wetter in that part of the world. What about in your part of the world? So the Water Balance app, fascinating to be able to do this at multiple scales for different variables. Okay, so coming back to our outline, let's take a look now. I've shown you 2 of many apps that they're already pre-built and ready to go. Now let's look at a couple of things inside the Living Atlas. So we start with the Living Atlas of the world. This is the main page for the Living Atlas. And I'm doing a search right now. I'm going to the Browse tab. So livingatlas.arcgis.com. Maybe Lisa can put that in the chat box, livingatlas.arcgis.com. Remember, ArcGIS is the ESRI flavor or brand, if you will, of geographic information systems. Thanks, Lisa. Awesome. And I'm going to search on wildfires. Okay. The array of data that you get is vast. Okay. And this is exactly why I had this. Remember this spatial reserves data blog. I want students to understand, to be critical of the sources. Now, in the Living Atlas, you have authoritative content. Again, it doesn't mean it's perfect, but it's from agencies that are responsible for science and data, okay? And so in here, we've got another nice thing about the Living Atlas is that there's metadata, there's data about each layer or each map in there. So current wildfires, let's take a look at that. So it pulls up the metadata page for the current wildfire. So you can make an assessment about, okay, who created it, class, how often was it updated, etc. Where did the data come from? Okay, how often is it updated? So this is a metadata page for that content item inside the Living Atlas. I never metadata I didn't like. Well, that's a little data pun. Ooh, it's very bad. Anyway, the point is, you're going to find some content at some point where you don't really have a whole lot of information. That's another nice thing about the Living Atlas. Every layer in there, it actually is populated with information about who created it, when, how, why, how often, etc. So you've got a couple of options here. Since we're going to look so much in the future on the 2D maps, I'm going to use this second button on the right here. I'm going to open it into our 3D scene viewer. because maybe there's some things I want to have the students know about. For example, this ridge behind me, this was the Pine Gulch fire. This is my home county, Grand Junction, Mesa County. But that whole ridge was on fire most of August 2020. And fortunately, not very many people lived up there. And so nobody was hurt and there were actually no structures damaged. But what about looking at things in 3D? Here we've got these wildfire perimeters, and I'm just going to, since I have that image behind me, I'm actually going to look at that in the 3D scene viewer. So now I've got the 3D scene viewer, and I can say, well, gosh, I'm going to look at that wildfire and I'm going to do some things with it that might be instructive. So, okay, it's up on this ridge. I can tilt and so on. I can see that it's above the valley. I can see some ridges there. I also have some tools at my fingertips. For example, on the right side here, I've got this measure tool. Look, I've got a line measure. I can look at the latitude and longitude. Fascinating. So if I do something like this, I can say, oh, well, gosh, look, it's 20, 30 kilometers across. Well, what about this? I've also got this. Ooh, I can measure I'm doing it really rapidly. I can, wow. So that's the perimeter and that's the area. So there's a little bit of math integration. How does this compare to the size of Denver or Boise or another city? It's a pretty big area. So I can look at this in 2D and 3D. What about a base map? What if I changed the base map and looked at this particular fire and then compared it, as I mentioned, and as you probably know, northern part of Mesa County. Okay, there's really not a whole lot up there besides wild horses and a couple of other creatures. But the point is, what if I compared this to a wildfire in Malibu? Okay, what's the land use like there? Why was that so much more severe in terms of at least human life? So you've got these tools at your fingertips. And this is part of the ArcGIS platform. So I'm just looking at one layer in the Living Atlas, in this case, wildfires. I can add other layers to it: population density, rivers, burn potential, etc. All right, we need to move on because there are so many. I'm going to close a couple of these tabs. But let's look at, how about stream gauges? Okay, so inside the Living Atlas, I pulled up the metadata page for stream gauges, and now I've got some layers in the Living Atlas are global, some are specific countries, some are USA. So sometimes people say, well, Joseph, I want students to kind of think outside the USA boundaries. Yeah, exactly. And that's why the Living Atlas is actually fascinating. Now, that said, we're going to zoom over here. We're going to pan. You've got in this case, a 2D map, but we could have looked at this in the 3D scene viewer. And right now I'm seeing, oh, well, there's a lot of, let's pull up a legend here on the left side. Major or moderate flood on the East Coast. So what happened there recently to dump a whole lot of precipitation over there in some of these gauges? Another thing that I love doing is, once you've got the layer inside this ArcGIS platform, notice up in the upper right, I am not signed into anything. I'm not signed in. I don't have to have an account at this point. Okay, again, if I wanted to save this map because the bell's going to ring, or I wanted to have it on Monday morning so I can show the students and I don't have to, go to the Living Atlas and say, add the stream gauges. I actually want this, like maybe zoomed into the North Platte in Nebraska, let's say. Then I'm going to need to save it, and then I'm going to need to have an account in ArcGIS Online to do that. Hopefully that makes sense. But even right here, I can say, gosh, even without the flood potential, I can go ahead and look at, this is just, I think it's really fascinating to be able to say, oh, well, if I go to this location over here on the Platte, let's say, so then it's going to pull up the NOAA stream gauge right there. So I can see, oh, okay, it's about 7 feet at the moment, 25 February. So in this case, you've got this real-time data feed coming in from the gauge on that. So 7, 8 feet, okay, cubic feet per second stage, okay. Talk to the students about what exactly that means. We don't have time to do it here, but imagine doing this. What if you click then, where does the South Platte flow, or the Platte flow into the Missouri, and then click on a gauging station there, and then the Mississippi, and then at the different points along the Mississippi, and see how, and it's not always so intuitive because of diversions in rivers along the way, but you can see that generally, if you go down to New Orleans, well, in 1814, we took a little trip. Anyway, if you go down to New Orleans, you've got like a 41 foot height. So getting the students to think about, it's not just these rivers flowing, but they get bigger, right? So getting them to understand river systems. And since you've got this in ArcGIS Online, if you go to the Modify Map button in the upper right, okay, now you've got an Add button on the left. And now I can say, ooh, browse Living Atlas. So this is the second way I wanted to show you how to bring in content. You can go to the Living Atlas page and do a search on wildfires or population density or hurricanes or other content and start from there. Or you can start with an existing map that you've already opened with a couple of layers in it. And then you can say, I want to add more data. Not that more is always better, right? But if it adds value to your instruction. So now I want to say, I want to browse the Living Atlas layers, and I'm going to look for ESRI hydro. So hydrography, or rivers. Okay, here is a map, one of my favorite layers. I'm going to add that, and now I've got two things actually, even though I added one layer. I've got, let's go to content and turn off the gauges for the moment. If I zoom out, I can see, this is another wonderful thing about these tools. At a certain scale, you've just got major rivers, right? So even if you're just going to use this as a content piece, you're not confined, and nothing against textbooks, I've written several myself, you're not confined to this map at this size on page 302 of your textbook of the rivers of the world. You see what I mean? You've got this dynamic set of content at your fingertips with just major rivers now. But if I zoom in, so now at this scale, right, I see the Mississippi, Ohio, etc. As I zoom in, though, I'm seeing the Platte system, I'm seeing the Rio Grande, and now I know a lot of you are from Colorado. So as I zoom to Colorado, what are those dotted lines? What are those dotted brown lines? We'll open up the chat here. What are those dotted lines in there, folks? Awesome. Thanks. Exactly. The watershed boundaries. So now I can see the Platte, the Arkansas, the Rio Grande, and the Colorado in Colorado. Okay. But if I zoom in, I'm going to see the sub-watershed boundary. So I'm going to go into like Western Boulder County. Now I've got additional rivers on there. And now I can see, oh, there's the South Boulder Creek versus the Clear Creek watershed. And again, if this is part of your unit about why do we care about watersheds? Admittedly, there's a lot of content in the base map, but no worries, mate. Go to base map and change it to something simpler, like terrain with labels. Okay, that's kind of interesting. What about even simpler, light gray canvas? Now I can really see the watershed boundaries and the rivers. See what I mean? So you've got this amazing set of content at your fingertips, along with, again, the live stream gauges, so we can see, well, what's it like right now? And then I'm going to check back with my students in a month, or maybe in April and May, when some of the snowpack, and hopefully we'll have some by then, some snowpack is melting, and look at these these river gauges and see what the height is, especially during the major snow melting part of the season. So that is two major ways of accessing the Living Atlas content. You go to the livingatlas.arcgis.com and you search and you access the layers there, or you're inside arcgis.com and you're using the add button and adding layers from there. A couple more things as we kind of work toward the end here. One of them is these, I mentioned, preview of coming attractions earlier. I wanted to show you folks the new ag data. The agricultural census data. So I can see here, okay, I'm on the Living Atlas page. I've done a search on agricultural census. And again, I've got a little bit of metadata here. If I click on any of these zones, I'm going to get a little bit more metadata. But I want to look at, just to look at the thumbnails here, I can see there's a vastly different pattern of cotton, for example. Let's just take a look at that. Cotton production, US ag census data. So again, where does the data come from? How does that get collected, et cetera, et cetera. But I'm going to go ahead and this time open it in the map viewer in the upper right here. And now I'm going to have that layer according to the agricultural census of cotton production in the US here at the moment, because it's US ag data. So, okay, there's no cotton production in Colorado in any of these counties that I can click on. Remember, this is the power of a GIS. There's actually data behind each one of these mapped layers. There's a database behind every one of these. So for example, we'll look at the spatial pattern right now. Okay, so what if you added precipitation or frost-free days, and the students are going to understand, okay, this has got a southerly influence on it. Now, some of these areas are wet and some of these areas are dry. So then you get into the, well, how can we grow cotton in West Texas? It's all, as you folks know, it's all irrigated. So we're actually mining the groundwater to irrigate the cotton. So you get into discussion about, how many years into the future is that going to be sustainable, et cetera? What are the impacts of that, on employment, on the environment, et cetera? But you've got this southerly influence. And let's say we wanted to actually dig into the data a little bit more. Inside every one of these layers, remember, a GIS is composed of those three parts. The G part is the map. The I part is the information behind the map, a database. We're going to look at that in a moment. And then the S brings them both together into a powerful tool. So right now we've got 3,070 polygons in this data set because they're counties, and there's a little bit over 3,000 counties. Okay, so we're going to open this and we're going to say, gosh, look at this. Area harvested for cotton. Production and wow, operations, sales. I've got information in here. So let's say we wanted to look at just sales, and I'm going to sort descending. So now we've got a county with $201 million. Where is that? I've got one record selected in the table right now. You can see 3,070. I've got one layer selected. And then I'm going to go over here to these three lines, and I'm going to say center on selection. Probably no surprise to you all. It's a county in California. It is Kings County. So if I zoom out, this is the Central Valley, right? And so again, you've got irrigated cotton fields. It's producing a lot of cotton compared to other counties, and there's other counties there. So with any layer, you can do a sort and figure out the biggest earthquake, the water well with the lowest pH, the part of the ocean with the lowest dissolved oxygen, etc., because you've got these tools at your fingertips. Okay, gosh, we're running out of time here, but a couple more things here, folks. And I wanted to highlight, let's look at the ecological marine units. I just had a little preview of that with you all, but this is, so many maps. This is another reason why I love the Living Atlas. So many maps have, the oceans are, a blue or gray expanse of nothing. And you've got data here at your fingertips where you've got this particular data set. It's got all these little dots on it. Every 10 kilometers, there's a data point. Ooh, so let's say this is your unit on oceans. Okay, I'm going to click up here in this part of the ocean. And notice here, ecological marine units. This is the characteristics. So again, obviously, if you're working with 7-year-olds, they're not going to know what nitrate is, and they're just going to know that that's cold. Okay, it's super chilled. Okay, but if you're working with high school students or university, right, you're going to get into some of the water chemistry. And then if I pan on down to, just east side versus west side of the USA, as you folks know, you've got a warm current coming up from the south, right? But on the west coast, you've got a cold current coming in from the north, and you can see the difference in the temperature and the salinity is even different. And why is that important? And why do we care about ocean chemistry? And why isn't all the ocean the same if it's all mixed up? You get into all kinds of interesting issues with the Living Atlas layer as a supporting document. I'm not going to say if you've got, let me just say this, if you've got good curricular materials that support your learning objectives for a certain unit, use them, okay? Don't feel like you have to force these layers in the Living Atlas, but if you have something that is not quite working the way you want it to, the students are not really engaged, they're not solving problems, they're not acting as scientists, then those would be the units, in my recommendation, that you would use pieces of this in, okay? Now, let me just close by one last thing here, and that is, Joseph, what's the best way to get into this besides going to the Living Atlas of the World? Well, I think one of the best ways to sort of dip some toes into the waters, get it? We were just looking at the ocean currents and the ocean chemistry. The waters of geospatial is to go to the geo-inquiries. The geo-inquiries are a set of, if you printed them, they're actually a set of 2-page lessons. And so I'm just going to look at one of these with you all. Now, one of them is called Investigating Biodiversity. That's the one I actually have right here in front of me. So you link to it's got links to the content standards, et cetera. but we have some leading questions in here that you can use or not use. I mean, you're all some of my favorite educators out there. And if you don't like the questions that we pose, fine, use your own questions. You know what I mean? But you can use these if you want to. So here, you've got a set of questions that students could actually, with your guidance, go into. But every single one of these lessons has a link, as you can see here, to a single web map in the same ArcGIS online platform. So if you open that, this map URL here, you're going to get this. Look familiar? Because it's exactly what we've been looking at for the last half hour, 45 minutes. So you get this map with biomes, as you can see here, abundance of original species, vascular plant diversity, flowering plant diversity, global mammal diversity, and global mammal carnivore diversity, each with the same capability as we looked at earlier, where you get a table of data and ability to filter things and so on and so forth, and a legend. Okay, so you know exactly what these things mean. Okay, so in the lesson, it says one of the questions is, where is the highest variety of vascular plants? Okay, let's take a look at that. This is one of the layers in here. So isn't this fascinating to look at this? Okay, so okay, understanding, okay, what is density? So number of vascular species per 10,000 square, what is 10,000 square kilometers? So there's some things that you might have to, which is actually good because there's a little bit of math integration here. There's a little bit of what's the concept of density, you know, depending on the age of your students, et cetera. So, okay, darker, higher number of species per land unit. Okay, so what do they notice there? Okay, it looks like near mountainous edges, the Andes, the Himalayas. Okay, why would that be? Why would, for example, well, let's look at flowering plant diversity. Okay, what about that compared to the other? Okay, different pattern now. And this is a different kind of a legend. Number of flowering plant families. Ooh, interesting. The density. Okay, why would flowering plants, for example, have subtle differences in distribution from other vascular plants? Well, then you could talk about, you know, flowering plants spreading through fruits, seeds, and pollen carried by animals, winds, and currents. Central America, you know, you could focus on that. Originated, as some of you probably know, island chains and provided some isolation, so allowing some flowering plants to migrate and speciate. I taught GIS in Costa Rica a couple times, and maybe some of you have been down there as well. As you know, the diversity of species in just 1 square meter is just absolutely phenomenal. So again, this map with these layers in it is tied to a single geo-inquiry. So that is a way to sort of dip toes into the waters. And we have a whole collection on environmental science that we've actually written in conjunction with teacher colleagues of yours. We have another section on earth science and for other math, history, etc. So this is one way of getting into this. Another way, though, is remember what I was saying. You go to the Living Atlas and you use a couple of those apps like the water balance app and the Wayback Imagery. You can go to, and I'll share this whole slideshow with Lisa. So you can actually, you won't even have to do much effort at all. You can just basically click, all these are hyperlinked. So you can actually click on things that we didn't have time to cover, earthquakes and population density. And in closing, again, you've got a lot of capability at your fingertips. In closing, I hope it, yeah, I know this is an environmental, you know, workshop right now, but we're going to take a look at, hey, we've got the Mars, you know, again, it's based on the same technology. So if I look at, for example, the rover, the new rover, right? So I've got a locations, and again, this is the 3D scene viewer. It just happens to be on Mars instead of the Earth, right? So I'm looking at the Perseverance rover. Where did it land? Why did we pick this place? Where do these satellite images come from, et cetera, et cetera? But even taking a look at, here's a crater just south of there. Why didn't we land on the edge of it? Well, let's take a look at, you know, you've got some measure tools here. So again, a little bit of math integration. I'm going to click on both edges of that crater, and I'm going to say, oh gosh, you know, even that sort of minor crater is like 1,000 meters deep. And it is, looks like it's about 7 kilometers across. You know, so have the students measure in ArcGIS Online, what is an equivalent, you know, go over here to you know, Denver or someplace. What is a 7 kilometer, right? You've got a measure tool there. What is a 7 kilometers? Let's change the units. So we're looking at the same units across. Well, that's like, you know, that's like Lakewood, It's a big crater. I mean, if that crater were on top of Lakewood, it would swallow up Colfax and, Jewel and some of those streets. Anyway, the point is you've got that capability, but you also have even better, I think, is, okay, I'm going to compare. And again, teaching about scale is a tricky thing. So the nice thing here is that you've got, okay, I'm going to look at the globe, and I'm going to look at, let's just take Colorado, and I'm going to place it on Mars. Okay. And so now I've got Colorado on Mars, this big, it's, as you know, it's not an exact rectangle, but what if I scrolled out here and I actually go over to a certain place? So I'm looking at those, those rift valleys and other features, Olympus Mons. I mean, goodness gracious, you've got a lot of tools at your fingertips here that I just encourage you to go into. Let's just take a look at this one right here. So if I compare, and I'm going to place, let's pick a different one. I know someone on the call here is from Idaho. So let's go ahead and pick Idaho. I'm going to pick Idaho and place it on this feature. This is a big feature. I know Mars is smaller than the Earth, right? But you've got this capability of looking at this stuff. Goodness gracious. Anyway, that is all based on the same technology. It's all ArcGIS Online. And I just highly encourage you folks to dip some toes into the waters. We really got into the living atlas of the world today. And I hope that was informative. Do folks have questions, comments, complaints?
Wow, that was fabulous. I am blown away by all of the technologies you just showed. And if you have a question for Joseph, feel free to chat it in or even unmute yourself. You can ask it directly. There's a question about where do you find the geo inquiries? Maybe we could pop that in the chat. Oh, you got it.
Well, no, the schools page is if you need an account for your school. So, if you wanted to save a map, if you wanted to make story maps, you wanted to use some of those field tools that we talked about. And I'm going to put the geo inquiries one in here. Yep. So, right. And again, folks, let's scroll down to how do I learn more? Let's leave that right here for a moment. There's one last thing to mention here, and that is one of my colleagues and I wrote a course for teachers actually called Teaching with the Living Atlas of the World. And again, you folks are wonderful educators, and you can just tap into that course just a little bit. You can you could skim it. You don't have to go through the whole thing. It's about a 2-hour course-ish. So basically, 3 times the amount of time we had today with this short webinar, but it really digs into some of these things. I know some of those things were a little bit fast, but hopefully it was just to give you a sense of, yeah, I can definitely use this.
There's one more question, Joseph, about if there are some geo inquiries for sustainable development.
Yeah, there's two places to look. Let's take a look at the in the environmental zone is one place. So these are the categories. And another place to look is the learn.arcgis.com zone. Now, the learn.arcgis.com zone is not just for educators. It is for everyone that wants to learn more GIS. So, but that being said, there are some wonderful lessons that actually guide you and students through specific topics. They're never just let's learn more GIS. They're all about hurricanes or land use, right? Or transportation or COVID or whatever the issue is. So if you go in here and look up conservation, you're going to find, hey, a lesson on species distribution patterns to assess protected areas. So that's the kind of thing that is in here. Rainforest deforestation in the Amazon rainforest. Not all of those are ArcGIS Online. Why do I say that? Because we have other products that I didn't have time to get into. So if I said, I highly encourage educators and students to start with ArcGIS Online. Nothing to install, online, as the name implies. You've got a set of about 40 analytical tools in there. I want to make a buffer around streams, so I can call that the riparian zone. I want to buffer that stream by 100 meters on each side, and I'm going to have a riparian. Those are the kinds of tools. Trace downstream, drop a drop of water on Continental Divide, Colorado, maybe just a little bit east of the Continental Divide. Where does it flow? You know, those kinds of things are inside ArcGIS Online. We have another product called ArcGIS Pro that has even more analytical tools, but I highly encourage you to start with ArcGIS Online. But the reason why I say that here is because if you filter just on ArcGIS Online, you're not going to get those other those lessons based on those other tools. Okay, so this, again, that species distribution one popped up. You can see it's about an hour-long lesson. Remember, this is for everyone. So if you're working with a 12-year-old, maybe double that, right? So etc. And you use your best judgment there. But that's 2 zones for lessons. Yep, I hope that was helpful.
That is great. And I know we are at time, so I want to be
Crudsville, it always goes so fast, Lisa. Oh my goodness.
It does, but I will follow up with everyone on the call here today with all these great links and the recording for today and Joseph's information if you want to reach out to him. Thank you, Joseph. This was just a mine of awesome information.
You folks are the real heroes. You're the educators and you're building a better and brighter future. So I salute all of you.
Well, again, thank you for everyone on the call and especially to Joseph, and we hope to see you at a future CAE event. Everyone have a great day.